Right, so welcome back. Without wasting too much time, let me just go right into the content, which is composite functions. So, first, what are composite functions? So now, um, so to define composite functions, I would say that composite functions are just a combination, so I'll write a combo of two or more functions. Okay, meaning now we saw the traditionally we saw the example of taking x and then you put inside this function f, then what you get outside is fx, right? Okay, so then you know x is your input. Okay, in this case we called x the fruit in our juice maker example, so f is a juice maker, right? And fx is your output, and this is the notation, right? We write the function outside, and in bracket we write the input. So we're gonna do this, but now with an extra process. So we have one function which is making juice, and our output, what's our output? It's the juice, right? So then let's say I take this juice and then put it into a packaging machine. Okay, and what comes out is box juice. So this juice here is no longer the final output. Instead, the box juice is the final output. So basically, I'm just putting my input, my fruit, into two processes instead of one. Okay, that's it. So first, from the fruit I'll get a juice, and then from the juice I'll get the box juice or box drink. Okay, minuman kotak lah. Okay, so now how do we write this function? How do we write this output here? So we know that now the second process is g, right? So we are applying the function g, and normally we put the input in the bracket. So what is our input for g? What are we putting into the function g? That is fx. Note it's not x, okay? It's not x. It is this thing here, fx. This is what we are putting inside g, right? So our notation will be like this. Okay, cool. So what is a composite function then? So now we have one function f and one more function g. And it's a bit hard for us to normally deal with two functions, right? So what if I go from x straight to the box juice, like so from a fruit, you take a fruit and then you straight away get the box juice in one process. So that is the composite function. So this composite function is a combination of f and g, meaning one function that will exactly do f and then do g. Okay, and what do we call this function? So the notation is a bit funny, but it will all make sense. Now this composite function is called gf. Okay, it's not called fg. You might be wondering why. Oh, f is the first process, g is the second process. Why is this reversed, right? So the idea here is that we are applying g to f. Well, this is not very important. It's not something that will appear on your exams and all this stuff. But then I'm just saying that you at least know why the name is terbalik lah. Okay. So this is, I would say, reverse notation. Okay, so if we do f first then g, our composite function is gf, not fg. Okay, and so if this whole function is gf and our input is x, right? So what is another way we can write the output? So we can also write this output g in bracket fx. We can also write this as gf in bracket x, right? Because gf is now a function and x is the input. Okay, nice. So now we will be doing composing functions. Okay, so how to make a composite function. So I'll go with an example. Say we have, so what we're doing here is, so this is function f and this is function g, right? And then what is this function called? We just discussed this. This is called gf, right? Okay, so then now I'll give you function f, I'll give you function g, and we are going to find what this shortcut function is, or in other words the composite function. So say fx is 2x, gx is 5x plus 1. So I want to know gfx. Alright, so we know that the output here is called gf of x, but this is also equal to, if we look in the last page, g with fx as the input, right? So let's just write that down here, g with fx as the input. And what is fx, by the way? Fx is equal to 2x. So let's just use 2x as our input, right? That's just saying that this thing here is 2x. If this is x, this thing here is 2x, okay? Now, so this is our output, okay, and it's equal to g of 2x. So we use 2x is the input for g. So next question is, look at this equation, gx equals to 5x plus 1. What this equation is telling us is that if you put an input of x, your output will be 5x plus 1. So can anyone tell me what gu is? If you put an input of u, you should get 5u plus 1, right? So same thing here, if you put 2x, you'll just get you'll just get 5 times 2x plus 1, and this is 10x plus 1, and so this is equal to gf of x. This is the output. This is the output here, okay, in terms of x. So if you want to go straight from here, if you want to go straight from x through the two functions, the whole thing, this whole shortcut here is to use 10x plus 1 as the function, okay, nice. Then I also want to tell you something very interesting, which is, now just for the sake of interest, try finding f g x and see. So you can do the same way as above. I'm not going to go through the working, okay? It's basically you do this and then, I mean, you just follow the working above, just that you use it for gx instead of fx, okay? You will eventually get 10x plus 1. Sorry, 10x plus 2. Sorry. You'll eventually get 10x plus 2, okay? So the point here is to say that, notice that this is not the same as gfx. So this these two functions are not necessarily the same. Well, they can be the same, okay? There are cases where f g x and g f x are exactly the same, but not necessarily, and most of the time they are not the same, okay? Okay, what f g x is saying is, it's simple. It's just a different process. So if you have a input x, okay, the first function is g and the second function is f, because we said if this is fg, then the process should be reversed, right? Terbalik, right? So it's g first, then f. And this process is not the same as doing f then g. Okay? You are flipping the processes. It's not the same. Okay? Cool. Now, we'll just finish up by doing another kind of problem. So this is the component function, finding the component function. Just now we did finding the composite function. So I give you two small functions. I give you f and g, and then I ask you, okay, find gf or find fg. Okay? But now, okay, so say this is gf, this is f, this is g. I will give you gf and either one of f or g. Okay, either one of this or this. So, and then I'll ask you to find the other one. So if I give you, so in the first case, I'm going to give you gf and g. I'm going to ask you to find f. Okay? And this is what we call this the inside case, meaning we are finding the inside function because we are finding the function that is inside. Okay, in this case the function f is inside. Okay, this function is the outside. Function g is the outside, f is the inside. Okay, later we'll do the opposite case, the outside case. So the example is, so I'll give you gx is oops, 3x plus 1, and gf of x is what? What's gf of x? So let's say it's 9x plus 1. Okay, nice. Now I want you to find fx. Okay, and the inside function of gf. Okay, but this is not important, so I'm just going to delete this to save space. Okay, now point is, always start with, so this is the first step. Okay, always start with oops, yep, so always start with writing it like this. Okay, then I would say in both cases keep your second step as letting fx equals to u. Okay, later I'll show you in the other case also. It's helpful to do this so that you don't get confused. Alright, for now you do not know what fx is. So in fact I would say maybe, so your first step is let u equals to fx. Okay, then the second step, the first part is to write like this, and this is equal to g bracket u, because u is equal to fx. All right, and this gu, okay, which is equal to gfx, is also equal to 9x plus 1, right? Nice. So 3 gu equals to 9x plus 1. But another information that we have is that gx is 3x plus 1, meaning if we put the input x, we'll get the output 3x plus 1 for the function g. So if now our input is u, then what is the output? What is gu? This is just the same as saying that 3u plus 1 equals to 9x plus 1. Okay, these are equal. Gu is just the output of u when you take the function g. Okay, so then you can do some quadratic equation and you will get u equals to 3x. And what is u? U is fx. So fx equals to 3x. We got our answer. We have already found fx. Alright? Yeah. So the next example is okay. So I'll give you gf and I'll give you f, and then I'll ask you to find g. Okay, g is what we call the outside function in this case. Okay, this is just to make it easy for you to see the steps. Okay, so I'm going to use the same gx as before, and I'm going to take fx to be the answer that we got here, okay, which is 3x. Okay, so what would you expect gx to be? I mean, since we already did the question just now, okay, we set gx to be 3x plus 1, right? So here also, I mean, it's the same setup. So we expect to get, okay, so our expect is expect gx to be 3x plus 1, okay, like the previous like the previous example here. Okay, and I'm going to show you that this is exactly what you will get. So step 1, again, like I said, let u equals to fx. Okay, for this outside case, I would say it's helpful to change your step 2. So step 2, what I would say is find x in terms of u. So you know the u is fx, which is equal to 3x from here, right? So then x is equal to u over 3. So this is going to be very helpful later, okay, just after this. Third step, do the same thing as step 2 in the inside case. Just write gfx as in this bracket notation here, okay, which is equal to gu, right? And this whole thing is equal to what? 9x plus 1, because this is gfx, right? And we have that gfx is equal to 9x plus 1. Now step 4 is we have that gu is 9x plus 1. And what is x? We already got x in terms of u. The problem here is that we have a u input and we need to change this to in terms of u. Okay, and this will help us to do that. So then if we substitute that, we will get 9 times u over 3 plus 1. Alright, and this is 3u plus 1. And so what this equation is telling us is that if you put an input u, your output will be 3u plus 1. So then gx is just the same thing. If you put the input x, you will get 3x plus 1 as the output. And that is exactly what we expected to get. Alright, so that's all for composite functions. I'll see you in the next video, and the next video will be about inverse functions. So have fun.